This video will explore quantum cloning and the physics of perfect light. We use lasers every day, but many don't realize they rely on a strange glitch in quantum mechanics, the ability to force light to perfectly clone itself. This is stimulated emission in action, which creates coherent, low-divergence light. Normal light, like from an incandescent bulb, is chaotic. Atoms release energy randomly, creating waves that emit at different times, in different colors, and travel in all different directions. Microscopically, it's a noisy, chaotic mess. The quantum setup begins with atoms absorbing energy and becoming excited. They naturally want to drop this extra energy and return to their resting state. If left alone, they drop it randomly, spitting out a chaotic photon of light. What happens if we intervene while the atom is still holding on to that extra energy? Stimulated emission acts as a quantum trigger. A passing photon, with the exact same energy the excited atom is holding, stimulates the atom. This forces the atom to instantly drop its stored energy. However, it doesn't just release normal light. Instead of one random photon, you now have two identical twins. The atom releases a second photon that is an exact, perfect clone of the first. It has the exact same color, travels in the exact same direction, and marches in perfect quantum lockstep or in phase. One clone isn't useful. We need billions. By trapping these photons inside a mirrored tube, we create an exponential avalanche. The cloned photons bounce back and forth, hitting more excited atoms. 2 become 4, 4 become 8, and so on, creating a massive, synchronized army of light. The word laser is not just a cool sci-fi name, it is the instruction manual for quantum cloning. It stands for light amplification, by stimulated emission of radiation. Amplification is building the army in the tube, stimulated emission is the cloning trigger, and radiation refers to the lockstep photons. That synchronized quantum army is in your pocket right now. Laser light is a tight, concentrated beam allowing scanners to read barcodes with precision. It also projects thousands of invisible infrared dots to securely unlock your smartphone with face recognition. The backbone of the modern internet is fiber optic cables. They only work because cloned laser light doesn't scatter, allowing it to travel across oceans in perfect lockstep. Your video calls, emails, and everything you stream are literally carried by these cloned photons. Normal light is chaotic, but stimulated emission allows us to force photons to perfectly clone themselves. We amplify this light in a mirrored tube to create a massive beam. Quantum physics is the invisible, synchronized heartbeat of the data, security, and communication technology we use today.